All right, this is Public Health 4040, and I left off talking about material that's found in Chapter 10, data interpretation issues, and I left off talking about sources of error that could be found within epidemiologic research, and I introduced the terms random error and systematic errors, and I want to spend a few minutes at this time talking in a little bit more detail about different types of random errors. So the first one that I want to cover that I'd like to discuss is poor precision, and this occurs when the factor being measured is not measured sharply. And an analogy that one can easily understand is if you were to go target practicing, or to go and do target practicing with a rifle, and you had a scope that was not in focus. And so here you would shoot the target over and over, or you would aim for the target, and if it's not in focus, there's a real potential that you would never actually hit the target. So how does that relate to epi research, or the type of instruments that are used when you're looking at study designs and that? And a way that you may be able to relate that to is looking at, for example, blood pressure within pregnant women. We know that pregnant women have a potential risk for developing high blood pressure. And so the way that you would try and improve precision is by increasing sample size within your study. So if you're only looking at 10 women and you have poor precision, as in you aren't the findings that you're expecting to find are not exactly what's coming out with the data that you're collecting, you can increase your sample size or increase the number of measurements, how often you would go and take a measurement. And so the way that I relate this is that my wife actually had high blood pressure with a couple of our children when she was pregnant. And she would take a reading at a certain time of the day, and it would always read really high. But then when she would go into the physician's office or the midwife's office, her reading would sometimes read normal, or it would read high. And so this is where the physician actually asked her to take more measurements throughout the day, from the time that she woke up to the time that she went to bed, to get a more precise measurement specific to her blood pressure. Another aspect when we talk about random errors is sampling error, and this occurs when the sample selected is not representative of the target population. And I've given this example in class, and the kind of questions that you could think about is that, are we to sample the target population or the entire target population? Does it make sense that if we're trying to do an epi study, do we have to sample everybody within a community, or are we able to actually just take a smaller sample and be able to then extrapolate those findings to the general population? So within class, I've talked about it where I can go and take 10 students that sit on the front row, and is that very representative of the entire class? And can I make an appropriate inference to that target population? And so another way to relate this, and this happens in surveys, is that could I issue a survey to you public health students, health education students, nutrition students, and take the survey data and be able to, and would it be then appropriate to extrapolate those findings to all of Utah State University students? And it may or may not be, but if we're looking at it from, like, for example, maybe a scientific type study where I'm collecting data and I'm looking at outcomes, you know very well that there's quite a few students on campus that are not science majors or have taken just the bare minimum general education requirements, and so the findings may not be all that representative of the target population. Sampling error also arises when the statistics obtained for a sample differ from values of the parent population. And this is, as I said, it oftentimes it's related to our sample population. So you can have a very statistically significant finding within this particular small sample population, but then when you extrapolate it to this parent population or to this larger sample size, you may have statistics that are insignificant or may not be of importance. There's numerous examples that are out there where students are able to relate to when we talk about sampling error. For example, in your high school or college genetics class, there's the marble game where you'll have a bag of marbles and you'll have to guess the color that comes out, and all of a sudden you can pull out 5 of the same color marbles, and it's just kind of this bad or this plain luck of the draw, or maybe bad luck. There's also, like, for example, the poker run or a run of colors in a roulette game where you're standing at a casino where every time the marble is dropped, it always lands on red, and there's no real understanding as to why that happens, other than it just happens. And so there's really no way to prevent a non-representative sample, other than you need to increase the sample size to where it will reduce the likelihood of sampling error. So as I've said in class before, instead of just taking the first 10 individuals that are on the front row, are we able to take 20 individuals and then maybe randomly select them throughout the room? And would that be more representative of maybe everybody in the College of Science or in the Department of Nutrition? And so that's the way that you would be able to maybe deal with sampling error. There's also variability in measurement, where there's the potential for the lack of agreement in results from time to time reflects random error inherent in this type of measurement procedure employed. So the goal ultimately, when we see variability in measurement, is to be objective and reliable, as well as try and obtain data that's accurate and reproducible. As I said, random error does occur, and there's ways that with increasing sample size or increasing the population that you're studying, those help alleviate aspects of random error. Whereas when I introduce the term systematic errors, this is often now how a study is actually designed, and it's just not random. It's a much more serious problem when we talk about validity of a study, when we have systematic errors or where bias is introduced. Systematic errors or bias is defined as the deviation of results or inferences from the truth or processes leading to such deviation. And it comes based on the collection, analysis, interpretation, publication, or review of data that can lead to conclusions that are systematically different from the truth. And there's many different aspects of bias or systematic errors that can be introduced into a study. And so this, as I said, this is much more concerning than a random error, because with random error, if you increase the sample size or you increase the diversity within your study population, you have a way to be able to remove or reduce that potential error. Whereas with bias, it's more based on the type of study design that's set up. So different types of factors that actually contribute to systematic errors, where errors can actually be introduced at any point in an investigation, can be grouped into selection bias, information bias, as well as confounding. And I've already introduced a couple of these in previous discussions, but we're going to talk about what these systematic errors are and the importance or the challenge that occurs when these are introduced into a study. So the first one is selection bias, and this is where you actually have distortions that result from procedures used to select subjects or influence participation in a study. So that's a mouthful, but it really comes down to how are subjects or individuals included or allowed to participate in the study. This arises when the relationship between the exposure and disease is different for those who participate and those who theoretically would be eligible for a study but do not participate. So the idea behind selection bias is that you want to be able to have a very, very representative component of the population. But when it comes down to who is going to be involved in the study, you may have an aspect of selection bias where it will distort the findings or the outcomes as a result. So the question comes up is, when can this bias occur? Can it occur before the study begins? Can it occur during the period of recruitment? as well as can it occur during the follow-up period of the study. So as I said, you have to ask yourself, when can selection bias occur when you're recruiting subjects to be a part of the study? And the answer is that bias can occur in all three of those scenarios: before the study begins, during the period of recruitment, as well as during the follow-up period of the study. You might ask yourself, what could potentially allow for selection bias, or how would this actually occur? And I can give examples of different types of clinical studies as well as epidemiological studies that are completed where selection bias does occur. One of the ways that individuals are recruited to a particular study is there are incentives that are often involved, and I showed that earlier when we talked about clinical trials, is that there is often an incentive, maybe a cash incentive to participate. You have to ask yourself, and there are strict rules now when you look at these types of incentives, is that would potentially a financial incentive ultimately bias the type of individuals that would participate in a study. Another component is that when you look at selection bias before the study or during the period of recruitment, is there a scenario where the study is actually designed to occur or where it's developed? Are we going to bias the type of individuals that would participate in this particular study? For example, if I were running a public health study and I were to do this particular study here in Cache Valley versus doing a study or doing the recruitment in Salt Lake, would I have different participation based on diversity because of the type of individuals or the races of the individuals that live here within Cache Valley versus Salt Lake or New York or Chicago? So a well-documented example of selection bias can be found within your textbook. It's published work that's out there specifically trying to understand women's health in Iowa, and it's the Iowa Women's Health Study. Ultimately, there was a survey, and the survey tool that was used by epidemiologists where they were trying to understand the demographics and the makeup of this particular population of women between the ages of 55 to 69. What this particular study and the way it was designed is they went and randomly sampled women, 50% of the women in Iowa, between that age range. But what was interesting, the way they designed this study is they were expecting to have the surveys returned by mail, but only the respondents, when they looked at the data, the respondents were younger, closer to the 55 age. They weighed less and were more likely to live in rural areas as well as less affluent counties than the non-respondent rates. They also saw that lower smoking rates in respondents than what was actually expected. So you have to ask yourself, when you think about a selection bias scenario and the way a study is designed, who didn't respond to this particular study? And you say, well, people that lived in rural areas and less affluent counties, they responded. So was it the more affluent women as well as those that are living in urban centers? Did they just not respond? And so now you have to ask yourself, when you look at the way the data is collected, is this really representative of the target population? And why didn't the more affluent women or affluent women living in affluent counties, why didn't they respond? Or were they just too busy? Or how was the data being collected? And did the study design individuals not set up the study in a way that would effectively collect that information across the representative population?